We have studied the physical properties. Now let us study the chemical properties of nonmetals. Chemical properties of nonmetals. When we studied the chemical properties of metals, we discussed that metals have a tendency to easily lose the electrons to form positively charged ions known as cations. And the reason for the chemical properties of nonmetals is that they have a tendency to easily gain the electrons to form negatively charged ions. The reason why don't they lose the electrons is that large amount of energy is required in the case of nonmetals to remove one or more electrons from their atom. So they actually readily accept the electrons, and in that process large amount of heat is actually released. So they have a tendency to readily accept the electrons to form negatively charged ions known as anions. So among the chemical properties of nonmetals, we have first of all the property which is the reaction of nonmetals with oxygen. So let us study the first chemical property, reaction of nonmetals with oxygen. First of all, I think the reason is clear that what is the reason behind the chemical properties? The reason is that they easily accept the electrons to form negatively charged ions known as anions, and therefore they are also known as electronegative elements because they form negatively charged ions. Now first chemical property which we are going to discuss is reaction of nonmetals with oxygen. When nonmetals react with oxygen, they form oxides. So when they react with oxygen, they form oxides, and the name of such oxides is nonmetallic oxides. This is very obvious as nonmetals are reacting with oxygen. So the oxides formed are known as nonmetallic oxides. Now what is the nature of nonmetallic oxides? The nonmetallic oxides are acidic or they can be neutral. So when we talk about their nature, we can say they mostly are acidic oxides, but some of the nonmetallic oxides are neutral also. How to see that the nonmetallic oxide is acidic or neutral? When the oxide is dissolved in water, it forms acid, then such oxides are known as acidic oxides. But the oxides which neither react with acid nor do they react with base, such oxides are known as neutral oxides. So first of all, let us see the reaction. What is the general reaction for nonmetal and oxygen? When nonmetal reacts with oxygen, what do we get? We get a nonmetallic oxide. So this becomes the general equation. Nonmetal reacts with oxygen to give nonmetallic oxide, and the nature of the nonmetallic oxide can be acidic or it can be neutral. First of all, let us study the acidic oxides. When I am writing the acidic oxides, I mean these are the nonmetallic oxides which dissolve in water to form acids. So they dissolve in water to form acids, and such acidic oxides are also known as acid anhydrides. Acid anhydrides, because these are required in the formation of acids. They react with water, they dissolve in water to give you acids. Therefore such oxides are also known as acid anhydrides. Now how to see that this is an acidic oxide? When we dip the blue litmus paper in such a solution, then it turns red. So what is the indicator used here? Here blue litmus We can use litmus solution also, we can use litmus paper also. So in this case, blue litmus paper turns red. So this indication tells us that the oxide which we have taken is acidic in nature. Now let us take certain examples. First of all, reaction of carbon, which is non-metal. Reaction of carbon with excess of oxygen. Here we will study two conditions of reaction of carbon with oxygen. First of all, this condition is when oxygen is present in excess. Now in the presence of excess of oxygen, carbon burns, carbon plus oxygen, it burns to give an oxide which is carbon dioxide. So carbon reacts with oxygen to give us carbon dioxide. What is the nature of carbon dioxide? The nature of carbon dioxide is it is acidic in nature. And how to prove that it is acidic in nature? One thing in that, its solution turns blue litmus paper red. Now it forms acid, therefore it is acidic oxide. So when carbon dioxide is dissolved in water, carbon dioxide plus water, we get an acid which is carbonic acid. And what is the formula of carbonic acid? It is H2CO3. And what category of acid is this? This is organic acid and it is a weak acid. So carbon dioxide is an acidic oxide. This we can prove that when it dissolves in water, we get an acid which is carbonic acid. What is the name of the acid? It is carbonic acid. So in this way we can show that the oxide which we have obtained is acidic in nature. Next reaction is the reaction of sulfur with oxygen. So second example we are taking is reaction of sulfur with oxygen. How sulfur reacts with the oxygen present in the air? When sulfur reacts with oxygen, we get sulfur dioxide. What is this oxide? This is sulfur dioxide. And what is the nature of this oxide? It is acidic in nature. How we can show its acidic nature? Because sulfur dioxide, when dissolves in water, we get an acid which is sulfurous acid. Its formula is H2SO3. What is the name? Sulfurous acid. Sulfurous acid. So I hope students it is clear that when non-metals react with oxygen, we get non-metallic oxide. Here we took the example of sulfur. Sulfur reacts with oxygen to give sulfur dioxide. What is the nature of sulfur dioxide? It is acidic in nature. Its solution turns blue litmus paper red, and moreover when dissolved in water, it gives us sulfurous acid. Therefore, it is also known as acid anhydride because it is used in the formation of acid. Next example. Reaction of phosphorus with oxygen. Reaction of phosphorus with oxygen. Phosphorus is also a non-metal. So when phosphorus, it is actually present as a tetra-atomic molecule P4. When reacts with oxygen, we get phosphorus pentaoxide with formula P2O5. Now students, when we try to balance this equation, we need to add certain coefficients which are 5 and 2. And what is the name of this oxide? It is phosphorus pentaoxide. It is also acidic in nature. How we can prove this? When it dissolves in water, P2O5, when dissolves in water, we get an acid which is phosphoric acid. What is the formula of phosphoric acid? It is H3PO4. It is phosphoric acid. And on balancing the equation, we need to add the coefficients here. So The oxide which is formed by phosphorus, it is also acidic in nature. We have shown this, that when it dissolves in water, we get an acid which is phosphoric acid here. So here we discuss the non-metallic oxides which are acidic oxides. Now what are the examples of non-metallic oxides which are neutral oxides? So second category we are studying is neutral oxides. As I told you that non-metallic oxides can be acidic or they can be neutral. Neutral oxides do not react with acid nor do they react with bases. So these neutral oxides we have, what is the example of neutral oxide? First of all, the example is when reaction of carbon occurs in limited supply of oxygen. Earlier we studied the reaction of carbon in excess of oxygen. Here is the reaction of carbon with limited supply of oxygen. When we have limited supply of oxygen, then carbon reacts with oxygen to give a neutral oxide. What is that oxide? Let us see. When carbon reacts with limited supply of oxygen, then we get an oxide which is carbon monoxide. And students, on balancing the equation, 2 before carbon, 2 before carbon monoxide. What is this oxide? This is carbon monoxide. And what is the nature? It is neutral. It is neutral oxide. So if somebody asks you the example of neutral oxides, the examples can be carbon monoxide. Next examples can be water. Examples can be water. Water is also neutral oxide. It is an oxide of a non-metal. Then can be NO. NO is also a neutral oxide. So when we talk of the examples of neutral oxides, there can be CO, which is carbon monoxide, water and NO. So I hope students this reaction of non-metals with oxygen is clear to you. Next we will take the reaction of non-metals with water. Second chemical property is reaction of nonmetals with water. So let us know how do they react or whether they react or not. So second is reaction of nonmetals with water. Reaction of nonmetals with water. Generally, nonmetals do not react with water, either hot water or steam, to release hydrogen gas. So they generally do not react with water. What we can write? Different from metals, nonmetals generally do not react with water. Do not react with water. Now what is the reason in this? When metals react with water, they release hydrogen gas. So something like that should have happened in this reaction also. So in that reaction, in order to release the hydrogen gas, the H positive ion which is present in water, that should be reduced. Now what should have been there? Reduction should have been there. And we know what is reduction? Reduction is gain of electrons. According to the electronic concept, reduction is gain of electrons. So in order to release the hydrogen gas in the reaction, the H positive ion which is present in the water, that should have been reduced. Reduction is gain of electron. Now only when this hydrogen, or when we have two H positive ions, say when it accepts 2 electrons, then only it will be able to release the hydrogen gas, otherwise not. Now we are reacting the water with non-metals. Non-metals, they have themselves the tendency to accept the electrons. So what do they do? Non-metals, they readily accept electrons themselves. Now when they only readily accept the electrons, there is no element which can give the electrons to the H positive ion so as to release the hydrogen gas. So actually this reaction generally does not occur. So when there is something given like carbon reacts with water, we know carbon is a non-metal, so non-metals generally do not react with water. So here we can write no reaction occurs. And the reason is that the non-metals cannot give the electrons to the H positive ion so as to reduce the H positive ion in order to release the hydrogen gas. So when such reaction, we can write no reaction. Another example can be sulfur also. Sulfur is a non-metal, so it also does not react with water. So we can write no reaction occurs. I hope the reason is clear, that for the reduction of H positive ion electrons are required, and non-metals are themselves electron acceptors, so there is no element to give electrons so as to release the hydrogen gas. So this reaction of non-metals with water generally does not occur. So I hope this is clear to you. Next is reaction of non-metals with dilute acids. So we are actually discussing the reactions which we discussed for metals also. In the case of the metals react with water to release the hydrogen gas, and they even react with the dilute acids to release the hydrogen gas. So let us see whether this thing happens in case of non-metals also. So third reaction is reaction of non-metals with dilute acid. With dilute acids. The same reaction we discussed for metals also. Now in case of non-metals do not react with dilute acids. So simply we can write they do not react with dilute acids. Actually in this reaction the displacement of hydrogen should have been there, but actually non-metals are not able to displace the hydrogen from the acid. Now what is the reason? Let us understand. The reason is that suppose we have acid, say sulfuric acid in the dilute form. So the sulfuric acid actually gives us two H positive ions and the sulfate ion. And in order to release the hydrogen gas from the acid, this H positive ion should be reduced, and we are reacting it with non-metals which are themselves electron acceptors. So these two H positive ions from the acid should accept electrons to release the hydrogen gas. Now when there is nothing which can give the electrons, so H positive ion will not be reduced to give the hydrogen gas. So actually this reaction does not occur. So we have, if we dip the carbon in a test tube which is containing dilute acid, suppose we have hydrochloric acid, so we can simply write when this hydrochloric acid is dilute form, no reaction occurs. Same we can write for the other non-metals also. The other non-metals like phosphorus, if we dip this or put this in a test tube containing the acid in dilute form, no reaction occurs. As non-metals are themselves electron acceptors, so they will not give the electrons to the H positive ion of the acid in order to reduce that. So that means here no displacement reaction will occur. So simply we can write no reaction. So both in the case of water also and in the case of dilute acids also, non-metals do not react. In the case of the water, generally non-metals do not react even with the steam, and here in the case of dilute acids, non-metals do not react with dilute acids to displace the hydrogen gas. So I hope these reactions are clear to you. Let us take more reactions.